Okay, here's one of those bounds questions where you have to think a little bit. We know that the volume of the tank is 1,000 liters correct to the nearest 10. So to work out the upper and lower bounds of that, it's 1,000 is our midpoint. If we go down 10, we get 990. If we go up 10, 1,010. So we know that the upper lower limits are halfway between the next possible values. So the lowest possible amount it could be is 995. The most it could be is 1,005. So that's the range of possible values for the volume of the tank. And then with the tins, it's 2.5 to the nearest decimal place. So obviously we go down to 2.4 and up to 2.6. So in between the tin volume, this is the tank, and then the tin volume is going to be between 2.45 and 2.55. Now to work out the number of tins required, it's going to be the volume of the oil in the tank divided by the volume of the tins. So normally, if it was just a tank has 1,000 liters in it, each tin has 2.5 liters. How many tins do we need? We do 1,000 divided by 2.5, and we'd get 400, and that would be the answer. But we want to know how many tins we might need to use in the worst possible scenario. So that would be if the tank had as much oil as it could possibly take, and the tins were as small as they could possibly be. Now, be careful here. It's the upper bound of the number of tins which were required. A lot of people would say that we work this out by doing 1,000 divided by 2.5. We get 400. And then like, oh, what's the upper bound of 400? 405. That's completely the wrong way to go about this question. We need to know that the volume of oil could be anything between 995 and 1,005. The tin volume could be anywhere between 2.45 and 2.55. So what's the most amount of tins we could possibly need based on that information? So it's going to be the highest amount of oil that there could possibly be divided by the smallest capacity of tin. That will give us the most outcome. And basically, if we're looking for the upper bound for a result and we're doing a division, we want the biggest possible number on top, we want the smallest possible number on the bottom. We do 1,005 divided by 2.45, and we get 410.204. And technically speaking, you should actually put the full answer down, but let's say, oh no, this is cunning actually. The number of tins would be required. If 410.2 tins are required to fit it in, we actually need to then go up and say that 411 tins would be necessary to fill it. If the volume of oil was such that 410.204 tins would fill it, then we need 411 tins to take the full capacity. So that's quite a cunning question. I'd say as bounds go, that's quite tricky.